Let's take a look at question number 3. The Voyager II spacecraft has long ago passed the orbit of the dwarf planet Pluto and is traveling through interstellar space. A radio signal traveling at the speed of light takes 16 hours to make it from the spacecraft back to Earth. How far from Earth has this Voyager II spacecraft traveled? Okay, so we want to solve for distance. Right now, you may recall this relationship. Speed is distance over time, or S is equal to D over T. Right, we want to solve for distance, so if we multiply both sides by T, right, cancels on this side, and we get distance is equal to speed times time. Distance is speed times time. All right. Now, we're told that a radio signal takes 16 hours. So we need to know the speed of that radio signal, and the time is 16 hours. So the speed of a radio signal is the same as the speed of light. Radio waves are just a certain form of light, a type of light our eyes aren't sensitive to. They're just much longer wavelengths and much lower frequencies than visible light. But it still travels at 3.0 times 10 to the 8th meters per second. Right, now, if we put our time in here, we need to have it in seconds so that the seconds will cancel. Right, so we have to take our 16 hours and go from hours to minutes, and then minutes to seconds, and we do this conversion. That's 60 minutes in an hour, and 60 seconds make 1 minute. We could always put this over 1, multiply all the top numbers. All the bottom numbers are going to just be equal to 1, and we get 57,600 seconds, and that's what goes up here. 57,600 seconds. And seconds cancel. And when you multiply this by this, you'll get an answer of 1.7 times 10 to the 13 meters. All right. Now that's just one way that we could do that. All right. If we do this another way, we're going to use different sets of units. Distance is speed times time. All right. The speed of light is also taken to be 186,000 miles per second. That's how fast a photon of light, in this case radio waves, that's how far they travel in a second, 186,000 miles. And from the previous solution, we'll use the time, the 16 hours, which is 57,600 seconds. We do that multiplication and we get 1.1 times 10 to the 10th miles. Okay, seconds cancel and we'll be left with miles. Now that's, if we take this times 10 to the 10th out of the, just expand the number, we're going to move this decimal point 10 places that way. It'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's miles. That is, right, 11, the number 11 followed by 9 zeros. That's 11 billion miles. And so if it's taken 16 hours for a radio signal to travel back to Earth, that means you're 11 billion miles away.